Okay, I think we should be going live. Yes, we are live. Let me know if you could hear me. Just let me know in the chats. Say hello, hi. You guys told me where you're from. We have some people from Massachusetts, Brazil, Colorado. I'm actually gonna send another invite to all of my people from Codecademy before we just get started. So just let me know how much you know about data science, machine learning, artificial intelligence, or anything related to programming in the chats. I would love to hear what you know about programming, and after sending this small, quick message, we'll just get started live in our stream. This is our chapter on Codecademy. If you're not registered, I would recommend going here and getting yourself registered as a member. Here's the link to the chapter on Codecademy. I just dropped it down. We also have a Discord server along with that, and I'll just log into that as well. But right now, I'm actually gonna have to send in the message to just let all of the RSVP people know that we're actually live. So we're just gonna go here, and I'm gonna send an email for the event, which is machine learning in Python. New email. Audience is the people who have people with virtual event ticket. An event is the machine learning one. We are live. Okay. Please join us at. Now we're just given the YouTube live stream link, which is this one, I believe. So let me just refresh it. I guess it's this one. Yeah, machine learning with Python. Okay. So we're gonna go here and just paste it in here. Okay, and I'm just gonna schedule, send this immediately. Awesome. So we send it, people will join in, and I would recommend joining the Discord server. I just got a quick message from, uh, okay, just got some quick messages, and we'll just get things started. So this is my Discord server. I would recommend joining this as well. I'll send you guys an invite, which is this one, copy here. And this is basically a community where I'm at, when where all developers helping each other out. So link, and this is the Discord server link. So I would recommend joining that server as well to just be updated with future events, because I do events every single month, and this month I've done two so far. And you can see the past events as well, which were being shown here in the chapter page. The chapter page is actually over here, so this one. If we go back to the Codecademy chapter page, let me see. So this is just going to take us to the Codecademy, but the community page. There you go. Um, and if we see over here in the chapter pages, this is the chapter page. So we have events that we've done in on March this month. We did about data science, Python, and Pokemon data set, and it was pretty amazing. You can see the live recording on the YouTube channel. So for those of you who haven't checked it out, I would recommend if you go to the YouTube channel, which is where you're watching this live stream right now. Just go to the live event page. So that's going to be actually just when you just simply search in coding cleverly. So suppose I search in coding cleverly. Okay. Okay, and then I go straight to the live here, live page right here. Yeah, and then over here you'd see this one, which is the Pokemon one, what we did 2 weeks ago. This is one last month, what we did on data science, just an intro, and then this was in January where we did machine learning. And my goal is to have events done every single month and probably more if the demand is right. So it's all about you guys. These are totally free. These are all my past events that I've done last year and the other. And this is all being done thanks to Codecademy. We have a chapter, and I would recommend joining it and being subscribed to the YouTube channel, of course. where you could get updated with more videos as well. So you'd have, you would have to see that there's so many up here as well, and all of that. So other than that, let's just get started with machine learning, and let's just see the chats and see the things about what people know about programming or machine learning in general. So let me just see if I go back to the chats. So this is the page that I'm actually going to view, and I could see we see that Francely is a beginner, so awesome. This is an event for beginners, so you'd love to see the basic stuff that we're gonna go to, and then after that we're just gonna advance our way a little bit with some of the things that we need to know. The essential parts here is Python because we're focused with Python programming language, and we're going to use Python to do some machine learning code. Okay. And if you have any questions, just remember to write them in the chats, and I'll frequently look into the chats and answer your problems. Other than that, let's just hop into the slides. So the slides are actually before everything. I prepared a really amazing folder where I have all these images, some diagrams, and there's some slides as well as some Jupyter Notebook files. And I would recommend people to just use them. So I'm actually going to create an infographics. So let me just say infographics. So wait a minute. So if I go back, I'll just get this and I'll wait a minute. So I'll just get all of these, highlight this and bring it in here. And then one, two, three. Okay, so let's just get this, this, and this, and just paste it in infographics. There you go. It's shifted there. And now we're gonna zip this thing up. So compress to zip file, and it should turn into a zip file. Mm, shouldn't take that long. Refresh. Let me just go back here. Downloads. Actually, it's in my desktop, so um, I have so many tabs opened up, um, which is not a good thing. Okay, so these are the things, um, and we just had to make a zip file for this. So send to compress the zip file. That's what I try to do, but I don't think so. It's working. So let me see if I could just compress this thing. So let me see, compress to zip file. Strange. Let's see. Oh yeah, you know what? We're gonna send these in the later on. So actually, I do have another zip file that I did prepare. So that one I'm gonna send right now, and it's right here. So paste should be optional to paste. Show more options and paste, paste, paste. Come on. Um, Copy and then paste here. Introduction to machine learning. There you go. Okay, so I'm gonna share this folder with all of you guys on the Discord server. Okay, so I can't send in the chats, so I'm sending it in the Discord server. So I'd recommend joining the Discord server with this link, where I shared this one, discord.gg. And then after that, once you're in the Discord server, remember to get verified. A lot of people make the mistake and not get verified. So if I could go to the Discord server, let me see if I could go. So this is the Discord server right here. And first of all, you'll be welcomed with this channel. Just remember to just verify yourself. So you can see over here 31 people. Just click on this one once. Okay, this just unverifies me, so I'm re-verified. So once you're done, you'll unlock all these channels. And you can see in the general page, you could see that some people are invited, like Fra. So I could know like people are invited. But I'm gonna send this zip folder in the useful resources channel. So over here you can see data science zip file, folder that I sent recently about Pokemon datasets. So I'm going to send this one, which is the machine learning zip file, zip folder. Okay, and let me just send in the attachment. So upload a file, and we basically go to that same folder, which is this one, um, and get the path here and paste it here. Okay, so I send this to you guys. Okay, the files are too powerful. The max size is 8 MB upgrade. Okay, so it looks like they're a little big, and I could send them through Google Drive. There's another option for that, and it shouldn't be a problem. So, uh, you know what? Let me just do it right now because I don't want to do this later. So what I could do is Drive, and it's not gonna take that long. It's gonna take really quickly. What I go to is basically to my Google Drive, and I'll just upload this zip folder, and from there you could just download it. So I'm copying it, um, and just waiting until this is opened. New file upload and paste in this zip folder, and it should pop up here, and it should load up. So once it's loaded, I'll just link it on my Discord server, and then you guys could quickly download it. So 1 minute left, and I'll remember to upload it there. And we can now start the folders, and I would just see if the size is 21.5 MB. So it shouldn't take that long. Yeah, so in the meantime, I could just talk about machine learning. So remember, like I said in the chat, do people know anything about machine learning or anything? I said just generally let me know. If not, and it's totally okay, let's get started. And I have these slides, remember, like I'm sharing every single thing that's going to be available, but let's just get quickly to the slide. So I go over here, this is the folder where you're going to open up, and you'll see other ML content. Here you could see other ML slides and linear regression. Where you can see other ML slides, you'll see this introduction to machine learning uh, slides, right? So that's going to be this. I'm just going to open it up, and let me just present it like this. Okay, so welcome, introduction to this session. Um, so machine learning is really popular right now, and we have to know what actually machine learning is. There's so many, big jumbo words that come across on the internet and everything. We know artificial intelligence, machine learning, and deep learning. But to get the difference between all these three terms, we'd have to think of artificial intelligence as an umbrella, an upper umbrella, and a big form to machine learning and deep learning because there's machine learning and deep learning are specifications, and artificial intelligence is basically a general term that could be used. So if we look at AI, we have any technique that enables computers to mimic human behavior. And we've come across so many AI tools online. A lot of people are using, different AI writers. ChatGPT is a big example of an artificial intelligence tool, and that's basically what it does. It basically mimics human behavior, and it has these techniques that computers manipulate, and they basically do the same things that humans do, ultimately doing their job. And then humans could do something even better, like do the creative things instead of the laborious things that do one by one. So machine learning is basically ability to learn without explicitly being programmed. And this is, remember, a term that is more specified, and it's ML. And we're not basically being instructing the computer to do it again. Once you teach the model a certain thing, it will remember it, and it will just keep doing the same thing that you have programmed it to do before. So once it's completely learned, then it could do the instructions without commanding it to do it repeatedly. So we could give an example of a robot. When you actually create the thing, then it could do the tasks without you instructing it to do it again and again, because now you have fed all the instructions beforehand, and now you just see how it's operating in real world. And deep learning is basically another specified term, and it's basically the root of all artificial intelligence. It's basically learn underlying features in data using neural networks. Um, and it just basically is a more specified and sophisticated term in the whole artificial intelligence realm. You could consider these all, and this is a pretty helpful diagram. So I'd recommend, checking it out when I share you it on the Discord server. After that, let's talk about what machine learning is. It basically roughly mimics the process by which humans make decisions based on experience, by making decisions based on previous data. Okay? Like I said, then the model will predict a house price that would be similar to the ones that it already learned, but it basically makes a prediction, and that prediction you could say more accurate to the other ones that without being trained. So, I mean, you could be confident that this is somewhat accurate, and the more data you provide the model, the better the accuracy gets. So it's just directly proportional relationship. Predicting today's stock market's prices based on yesterday's prices and other factors of the market. Um, Detecting spam and non-spam emails based on the words in the email and the sender. This is amazing because now the AI models could now determine whether an email is a spam or not by looking at the contents, and you basically train that model to determine these. And this is one important thing that I came across, and I would have to like to discuss. There are two different types of machine learning models. One are supervised machine learning models, and the other ones are unsupervised. And let me just quickly show you an image what I'm talking about. If I go here back um, to the infographics, I have an image of supervised and unsupervised chart. So supervised learning is basically labeled data, and unsupervised learning is unlabeled data. Now you might be asking, what do you mean by labeled and unlabeled? When we give the model some information, we give the training part. Remember, like when I say when we're training a specific model, we give some data to it. So that data is basically the labeled data and unlabeled data. Now, just let me see if, okay, so that means the file has been uploaded, and all I'm gonna do is now share it. So this is there, and I basically go right click. I guess it's like, yeah, so right click and get link, and come on, loading, 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 just wait. Restricted, and let's give access to everyone so that everyone could download this. Okay, I don't know why it's going so slow. Okay, it's not even clicking for some reason. Let me see. Is everyone there? Okay. Uh, YouTube is not receiving enough video to maintain such viewers will experience buffering. Can you guys still hear me? Let me know. Let me just see. Uh, come on, come on. Let me know if you guys could still hear me. Just want to know. I think it's working now. Come on, come on. Yeah, I think it's working now. There was a small delay, but now, yes. Yeah, perfect. It should be working for everyone. Sorry about the small, problem. But yeah, let me upload that thing, like I was saying, and let me just share it in the Discord server, and then let's continue off from where we did. So I went here, and I'm gonna cross that out, right click here, and I'm gonna share, and I'm gonna basically anyone with this link and copy link done. Let's go back to the Discord server and paste it up here. Okay, and then let's just send it here. And I'd recommend to check it out. Once you download it, just get this thumbs up. So go here. It should take you to this Google Drive link, and just click on this download button right here on the right side, and then it should download onto your local machine, and you would see all this material that I'm gonna go into. Um, so just give a thumbs up here into the Discord server. I'd recommend joining that stream here, which is right here in this link. Let me just see a lot. Yeah, let me repeat everything. Yeah, no problem. Don't worry. And this is remember this is gonna be recorded. So you're gonna see the things are gonna be recorded. If you have anything that's messed up or missed, it's gonna be repeated. And I'll definitely just go into what I just said. And I didn't go into anything big right now. I just said that I uploaded the contents on the Discord server, so you could check it out here, which is this link. Let's see if I could. Let me just see if I could share that Discord server link again. So here, come on, there, right, invite, copy and Discord, Discord server. There you go. So some people had some bad connection. As for me, it was too. Yes. Yeah. Stream working better now. I've been getting a lagging video. A lot of what you were going over for machine learning just skipped. Can still hear you now. Yes. Yeah. I could go over to that. Definitely, no problem. Okay. So I did share the thing. Let me just repeat what I said. I did share it. So what you do is basically go to the Discord server, get verified, and download this thing. So I could see that two people already did it. So yeah, we have Fran who's already downloaded that Google Drive file. Just open it up, download it, and let me just go into that slide again, and just quickly explain what things work. Okay. So I said what machine learning is. It's basically very popular now, and everywhere on the internet, everyone's talking about it. What is this trend, right? And we talked about the different three terms. One is artificial intelligence, machine learning, and deep learning. We said that AI is basically an upper umbrella, and machine learning and deep learning are subcategories, but the general upper umbrella is AI. So AI is basically mimicking human behavior and enabling computers to do that exactly. So you don't have to, do the same step-by-step task again and again. You could just program it and make a computer do it. So you automate the task, and the computer could do it automatically. Machine learning is basically the ability to learn without explicitly being programmed. So once you give it, once you train a model, you no longer have to train it or command it to operate. Then it could go on its own and perform its operations. So I could say that AI was the example of ChatGPT, which is pretty popular. Machine learning is also, like I was saying, like it's mimicking real world. And deep learning is a smaller subcategory, and it's basically an advanced form, advanced field, where we basically learn underlying features in data using neural networks. And it's a big, sophisticated branch. And I'm not going into that much detail about deep learning, but what we have a general overview, and this diagram is pretty helpful about the basic difference between all these terms. And basically, they're considered as something similar, but you can see now there's a little bit of differences between them. So, the general term is AI. Machine learning, like I said, it mimics the human behavior and it makes experience. Basically, it creates decisions on experience by making decisions based on previous data. Um, and I gave you an example of some, um, machine learning examples, like I would say predicting house prices based on the house's size, number of rooms, and location. Like suppose we had a sheet of data, and we had so many different house sizes and number of rooms, and also the location. So we basically have labels. Um, and we gave up, the result is basically the price of the house. So three different features were the size of the house, the number of rooms, and the location. And because of these three features, we had a one data result, which is the price of the house. So if we feed in like a certain number of house prices, and then we basically ask the model to say, we give another, suppose data set, but we don't give the result then. We just say, here's a new house with the house size, with the number of rooms, and a location. Now give me a good, accurate, maybe say, let's say an approximate amount of price that this house could be. So that is basically that training and testing process that we're doing with our model. And then we're doing this predicting today's stock market prices based on yesterday's prices and other factors of the market. And then I said detecting spam and non-spam emails based on the words in the email and the sender. So this is pretty cool because uh, we're detecting email that is maybe phishing or you know erroneous, and we could just determine it based on the text of the email as well as the sender. And this is also an act of machine learning. Play games like chess or Go, and then there's so many other like recommending videos or movies to a user based on their recommendation system, all which is being implemented on YouTube, Netflix. Pretty amazing. And then training self-driving cars to navigate a city by themselves, which is also done with machine learning. And it's pretty amazing. There's so many other applications, and these were just a few. Now, I wanted to give the differences between two different kinds of machine learning. Remember, I said that there's supervised machine learning and there's unsupervised machine learning. There are two different terms. So one is supervised. Okay, what does supervised mean? Supervised means labeled machine learning. Okay, and unsupervised means unlabeled machine learning. If I could go back to the chat and see if there's any questions, I think we're going great so far. So, and I feel like things are going smooth. So I'm just going back here, uh, and like I said, if I go back here to the dogs, see over here. So it just basically starts there. So dog, cat, cat, and cat. Remember, this is an image, and then there is a label to it, a dog. Okay, this is an image, and then there's a label to it, dog. Okay, this is an image, and there's a label, cat, cat. Okay, so that means this is label data. This is basically supervised. Label data again. We have 18 pounds, and this is a dog. 14 pounds, a dog. 9 pounds, 12 pounds. Again, some label and then the data. So this is label data, and this is known as supervised machine learning. Whereas when we don't have labels, these data, we have just have the data, but not the label associated label. So on the unlabeled data section, we just have an image, 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 and I don't know what it is, but I'm just giving in the data, and the model itself basically classifies and creates some classes based on the data. So that's unlabeled data, and it's called unsupervised machine learning. Now, unsupervised learning, you can see clustering. This is the concept that coming into. So over here you can see one email. The size of the email is 8 MB, and the recipient is 1. Then there's another email which is a 12 MB, and then the size is 1. I mean the recipient is 1. And you can see the number of recipients. The more the number of recipients, the size of the email gets bigger. I mean, in the 26 number, we have this, and then we have this 9 email. So there's just a relation, and then there's a graph. Basically, you can see over here, 10 KB, sorry, of email, and basically the recipient is like 1 or 2, and this is just a graph. So just an example of unsupervised learning clustering, which we don't have any labels to. And don't worry if you didn't get this, because I'm going to explain it in a better sense. Uh, Clustering example is like market segmentation, genetics, medical imaging, video recommendations. Now this is the example of dividing users into groups based on demographics and previous videos watched, and using this to recommend to a user the videos that other users in their group have watched. Now this is an example of unsupervised learning, where we're not using labels, but we're using other terms of data like demographics and recommendations or personal likings of things, so that the like social media platform like YouTube or Google or Facebook could recommend you some videos based on your interaction on the website, or your likings to particular things. Now, if I go and show you an image of what I'm trying to get across, is basically supervised and unsupervised learning. And this is basically a cool difference between the two. Input data is labeled, which is supervised, and unsupervised is not labeled, so input data is unlabeled. This is a basic difference. But when we have supervised learning, we has a feedback mechanism, and in unsupervised we have a no feedback mechanism. This could be like, remember, like I said, when we have that image of a dog, and we have that label with a dog, so we got a feedback that it's a dog, right? And then when we train our model and we give it another image, if I go back to that particular slide, now if I give another image, let's say I give an image of a new different cat, okay? And my model is trained. No, don't think about this thing now. Just think about these two, 1 and 2. Now, if I look at this one where we had dog, dog, cat, cat. Now, if I give a new image of a cat, suppose a cat that doesn't exist here, and then I give my model, so I give that, the model should determine the label cat. So that would be the result of the process, and that is the feedback that we get. But in the unsupervised, we don't get a feedback. Basically, it divides it into clusters. Classification. What we're saying, data is classified based on the data training data, and that is correct, assigns to properties of given data to classify it. So like I said, it classifies data into classes, and this is classified based on the training data set. Divided into regression and classification, and this is divided into clustering and association, used for prediction and used for analysis. If we could go into this diagram, I think this is more helpful. You can see that machine learning, let's see, no, we don't have a pen here. Sorry if I'm coughing a little. I'm actually a little sick, but I'm taking medicines. But I'm still with the session. So uh, this is the machine learning, and we have supervised learning and unsupervised learning. Okay. Now, like I said, remember it's divided into these two terms, and we already talked about supervised, where we said labeled, and unsupervised is unlabeled. Um, and and the diagram, the difference, what it said over here, it said that supervised is divided into classification and regression. You can see over here. And unsupervised is divided into clustering, and the other one is association, which is not listed here, but it is. Supervised, remember we said develop predictive model based on both input and output data, and it's giving a prediction. This is a basic term you have to know, that it's giving an accurate prediction, while unsupervised is not giving a prediction. It's basically resulting in an analysis. This is the crux of what we're trying to say. It's used for prediction, while the other is used for analysis. Now, algorithms include decision trees, logistic regressions, support vector machines, SVMs, and there's so many others like decision trees, and then there's random forest. And if we talk about the analysis part, we have k-means, clustering, hierarchical clustering, and this a priori algorithm. Sorry, I don't know how to pronounce that, but yeah, these are the algorithms for the unsupervised learning. Now, if we talk about a known number of classes, and we have a unknown number of classes, and you can see over here there are some data points here, and over here they're basically being divided into classes, right? Clusters. And this is just discrete. We know for this particular input there's a this particular output. So that's a predictive analysis, where this is analysis. This is predictive while this is analysis. So I think we're done with this, and we can move on. So this is another cool diagram that I wanted to show. If it's not that clear, let me go into the web page and show you the example. If you have any questions, you could ask me here. If there's anything you have, uh, I'm right here to answer your problems. But we can move on. And this is the thing that I was wanted to go through. So supervised, remember we said there's regression and there's classification. Now in regression we have linear, polynomial, regression, decision trees, and then we have random forest. Whereas classification models, we have KNN, trees, logistic regression, we have naive Bayes, and we have support vector machines. If we talk about the unsupervised part, we had clustering and dimensionality reduction, SVD, PCA, K-means, and association analysis. We have this one, the one that I don't know how to pronounce, and FB growth, and we have hidden Markov model. So really big terms, and it's okay if you don't know all. I don't know all, but we're just getting an overview of what the differences is, right? Now, if we could go back and go into the slide, and once we complete the slide, I'm gonna go into the cheat sheets where I prepared, and I could show you the basic end results here. So remember, like in clustering, we said, the unsupervised part where we're basically dividing users into groups. If we talk about video recommendations, but in genetics, you could cluster species into groups based on their gene similarity. We talk about market segmentation, dividing customers into groups based on demographics and previous purchasing behavior to create different marketing strategies for the groups, which is very useful for companies, especially those that are online. If you look at unsupervised learning, dimensionality reduction, it is beautiful because you have dimensions, or you could say features, and it basically uh, reduces the number of features, and it basically creates a general form of a feature. And this is that example of unsupervised learning. If we talk about dimensionality reduction, let's look at the example of a house. Remember, I said the house has a specific size. It would have a number of bedrooms. It would have a number of bathrooms. It would have a crime rate in the neighborhood and a distance to closest school. Now, if you can see, we have branched these two top and the bottom two and the top two. And the first two, we could say number of bedrooms and number of bathrooms. We could just say as a general size of the house. as well as the size. So I mean, 1, 2, and 3. First three are basically the general size of a house. We reduce the number of features into a general feature, and that is known as dimensionality reduction. Whereas if you look at the crime rate in the neighborhood, distance to closest school, we could reduce that and generalize it into neighborhood quality. So now we just have two features instead of these one, two, three, four, five features, right? So we reduce the number, and I think this is pretty better, and I believe you should think so too. So, and it says over here, it simplifies data without losing too much information. That's called dimensionality reduction. If you look at unsupervised learning dimensionality reduction, we have one dimension which is number on a street. Say street number, okay? So street number 8, that's street number 5 over there. If you look at two dimensions, address in a street. Now, we have street and avenue. So we have street number 5 and avenue 3, okay? If you look at three dimensions, we have address in a building. Now, we have street, avenue 3, so street number 5, avenue 3, and floor 4. So now we're getting closer. So the more the number of dimensions, the higher the accuracy. And look at this, address in a high dimensional parallel universe. I mean, we're just getting more and more informative, and we're getting more and more accurate. So if we look at this, we have 5, 4, 7, minus 1, 1, 9. 5, 3, 4, 7, minus 1, 9. So it's just getting more and more accurate. And you can see, like, if they're talking about one position here, and they're saying that the person is existing there, but now you could say, like, the person is, let's say, the person is on the Earth, if we look at more dimensions. Then it's in, let's say, the continent, North America. Then let's say it's in America, the country. Then it's in New York. Sorry. And then we have the state as New York, and then we have the city as, Manhattan, and then we just get closer and closer, and that's more and more dimensions. I'm gonna have to pause here and drink a little water, but I'm here. I'm here for the questions, so you could ask me some questions, and I could go into your questions before we, go into more detail. So I'm going back to the chats and drinking some water. So you could ask me some questions, and I could go into your questions before we, go into more detail. Hmm. Haha. Thanks. Yeah, water is important. Very important. Well, I'm gonna be using the Jupyter notebook. I have plans to use it, and I have it installed and everything. And I have some Jupyter files as well. I'm gonna look into these. Oh yeah, got it. Yeah, I know. The more programmatic. I like the term technical because I've done all of my sessions technically, and this one I just had some little bit of slides which I wanted to go over because I thought it would be really important to know some of the abstract terms and theoretical terms before we dive into more technical aspects of machine learning, and which is important, and I guess very important to know if you're learning machine learning. And if we don't make the time for that much, but we could do another one after you know after some time. Let's see, why is this happening? Yeah. Yeah, if we don't make if it's not possible, then definitely we could do things in the future. Remember to stay there on the Discord server and the YouTube to be updated, and you could always suggest me stuff like what type of events we should do in the future. Okay, So I think we're pretty much clear with the unsupervised learning and supervised learning and dimensionality reduction, where we reduce the number of features into less condensed features. Now, what is reinforcement learning? And I'll just give you a basic information of what this is. So reinforcement learning is a different type of machine learning in which no data is given and we must get the computer to perform a task. So we initially give no information to the computer and we basically test the computer and it will learn from its mistakes. Instead of data, the model receives an environment and an agent who is supposed to navigate in this environment. The agent has a goal of or a set of goals. The environment has rewards and punishments that guide the agent to make the right decisions to reach its goal. Just like life. Suppose there's a guy and he's in planet Earth and he has no idea what goes on. So basically he learns from his mistakes and he basically reaches his goals at the end. So similar to that, we could think of reinforcement learning, something like that. If we look into this example, which is pretty cool, we have this robot that is standing here on a grid, and it wants to reach the chest here with treasures. But before that, the score is 0. The robot has nothing known, only it knows that it has to reach the treasure chest. Okay? And if the robot reaches the dragon, we lose 50 points. To make sure our robot moves quickly, we can say that for every step the robot makes, we lose 1 point because the robot loses energy as it walks. So these are just some particular constraints that we give, and then the robot basically does its work, and if it makes a mistake, it learns from it, and continuously it finds the best path to move to the treasure chest. And that's reinforcement learning. Okay? This is particularly applicable in games like chess and other games, and you'll see self-driving cars are also using this robotics as well. If you look at self-driving cars, they help the car carry out many tasks as path planning or behaving in a particular environment. So the agent is the car, and the environment is the place where you're driving the car. So this is reinforcement learning. Cool. And I think we got into the detail. Yes, thanks. Great. Okay, so now let's go into the cheat sheets that I have prepared. Now you might be asking, where are these cheat sheets available? Well, these cheat sheets are available on Gumroad. And if you go to codingcleverly.gumroad.com, which wasn't working in the beginning, but now it's actually working. We have this page, um, and we have these machine learning cheat sheets. This one, and they're actually for $5. But basically for the first 5 people that join the Discord server, and um, let's say the first 5 people who join the Discord server and introduce themselves in the channel here, over here, introduce yourself about programming, I might give you a free copy of this. Okay? It's for free. So for $5, the first 5 people. But then the rest will have to pay, definitely, because there was so much effort to basically create these. But if you're like just wanna, pay it, then that's totally fine as well. Um, so again, the link to this would be provided as well. So Gumroad. These are better because I basically prepared them myself, and they're really easy to read, and you'll get really good at machine learning, I guess. So let me just share this here into the YouTube link here, cheat sheet link. Okay, so once you you get the thing. Let's say it's this one, ML cheat sheets, $5. You just download it. So I basically did it, and then it comes here as their ML cheat sheets. So I just download it. Since I already have it, I don't have to open it up again. And how it looks like is like this. So now we already got this cleared, but it not works and no problem. Let me just summarize what we know about machine learning. We have this particular model, let's say, a dummy model that has nothing that it knows, and then we train that particular model. We train it with some training data and some testing data. Okay, when we particularly train that model, it turns into some machine learning model. Suppose we had an image of a dog and we had the label of a dog, and we basically fed in the image and the label to the dog, so the input and the output to the result, and we did this like 50, 100 times with different images of different animals and their respective labels. Then we have this trained model, and then suppose we have a cat, unlabeled, and we given the image of a cat. We want the model to predict a result. Give us a result, let's say cat, dog, okay? Based on the image. We have the result, which is cat, here as well, which is our ground truth. And we basically predict and determine if the predicted value is equal to the accurate value. If that is successful, this is when we could conclude that our model is working perfectly, and we could say that our testing is successful and we have done machine learning. If not, then we're gonna have to retry again and again until we get a perfect result. Supervised machine learning, I said we have done with labels. You could do everything in machine learning, but the neural networks part is recommended to do with TensorFlow and PyTorch. I remember that I said that we've done this before with the machine learning session where we talked about iris flower types, where we have setosa, versicolor, and virginica. The aim of the machine learning model is to predict what color is passed, um, what type of color is what type of flower is passed. So basically, we could use this Python code from sklearn datasets, import load iris. There's a sample dataset in sklearn. We have load iris, which is an object. We load it in an iris. We basically type in typefig iris to get a bunch, which is a dictionary. We have feature name, which is the name of the features, which we have these. So 1, 2, 3, 4 are the features: the length of the petal, the length of the sepal, the length of the sepal, and the length of the width of the petal. So these four: sepal length, sepal width, petal length, petal width. These are features, and the result, which is the data, is this. So these are the values for the lengths and widths. So this is called as classification, supervised machine learning, where we basically have this predicted results. If you look at this over here, we have X and Y, and we have this. These are all provided in my cheat sheet, and I'm not going into the detail with KNN because I've already went through this, and I hope now we could go straight to the training and testing part, which we have, which I want to generalize quickly. That we suppose we have this model. 75% of the model is going to be trained, and the 25% will be used for testing. Okay, 75 and 25%. That means if we have 150 instances, we'll have to split 120 to the training and 30 to testing. If we have the random 75% training and random 25% testing, this will happen all the time, right? To stop the randomness, this is going to happen by default, so it's going to pick randomly 75% and 25%. But if you want to stop the randomness to determine what results it is, you could use the random state is equal to 40, which is a parameter in Python, which is totally okay if you don't know. I'm just saying that you have to know these. Just an overview of what I'm actually going to try to say. We have the random 75% training and random 25% testing. This will so just an overview, you don't have to go into that much detail. I'm giving you a general concept of what's going on. So we have a target, let's say we have a zeros 50 times, ones 50 times, and twos 50 times. This is our array, okay? So zeros are indicating the first type of flower, which is this thing. Wait a minute. So it's this one up here, this one, which is setosa. And then the versicolor is 1 and the virginica is 2. Let's say we have ones, zeros, ones, and twos. Now, there's a probability, a 33% of probability that the 0 will become 1 or 1. But you can control this, but ratio will be changed when train test split. To solve this problem, where you could have, customized, because you want a random train test split. Uh, the split train and test should be random. You could, because that's the goal of machine learning, to access every case and to basically improve your model to judge any kind of particular scenario. So to do that, we could use stratify is equal to y. Just a concept. It's just a code that parameter that you add in. in your machine learning model. So not too big. Okay, uniform distribution is like, uh, you know, there's two types of uniform distributions. I'm just giving you an example of this. One is uniform, and the other is weighted. Now, let's give an example of, let's say, a voting system. Let's suppose that the U.S. elections are going on, and the two candidates for being a president is Joe Biden and Donald Trump. Now, people are being generally what we use is uniform distribution. Every person has an equal vote, so everyone has one. Suppose the vote point is one. Everyone has one vote. So, if I go vote, I could increase the count of votes by one. And if another person goes, it also affects one time. But if we had weighted votes, that would mean that one particular person would have a different value of a vote, while another person would have a different. Suppose if there's a PhD guy who's who has a PhD degree or maybe a scientist, he would have a +5 vote, while another guy who's might not have a scholarship or any degree, he would have a +1. So that is difference here, weighted and unweighted, supposed to know. And then there's cross-validation, and then hyperparametric tuning. These are some concepts that we need to know, but I'm just giving you a general overview. So what is information leakage? Now I would just give you an example of what information leakage occurs. Suppose you have this training. Remember I said that 75% and 25%, right? So suppose like you give a math test at school, so you prepared the last night, and you go to the next day to your class and you take the math test, and what happened is that you got a 75% result. Okay, which is not good. And you go to suppose the next week the same test occurs, but now you learn from your mistakes and you get an 85%. The same type of test occurred. So the same, syllabus, and you knew what the questions and results going to be. So you trained your model, meaning you trained yourself, and you tested yourself, and you got a better result. But and then the third week, what happened? The same type of test occurred with the same syllabus, but now you got 95%. So now what you're doing by the passage of time, you're increasing your results, and you got a 95% result in your test. Means that you are basically learning and you are leaking your information, and that is not a good thing. We don't want something like that because the test is basically the same thing as the training set. What you're training with, the test is going to be automatically the same thing. Suppose you're in exercise 2 and you're solving exercise 2.1, a mathematical problem. And suppose in the test 2.1, the same type of question occurred. So you say, hey, that's what I did at last night. So you just basically do the same thing. That is information leakage. And you don't want this. So to prevent that, um, this, we basically use unseen results, where we basically split it randomly, not the first 25, 75%, 25. We change up the train test split, and we use cross validation to basically satisfy this thing. So this is how we do it. We basically test it with every single aspect. So let's say the first, we basically cut it down to folds. So these are like folds, one, two, three, four, five. Suppose it's like the 150 instance thing, the same, the whole total 100%. So it's separated in folds. Um, just checking if the audio is still working. Satisfy this thing. So this is how we do it. We basically test it with every. Yeah. So it's basically cut it into folds. So the first fold is basically fold 1, fold 2, fold 3, fold 4, and fold 5. So we test it with the first one, we test it with the second one, we test it with the third one, we test it with the fourth one, we test it with the fifth one. Now we have confidence that we have tested it really great. We take out the mean value, and that is now your best score. That is cross validation in general sense. Um, and we stratify, split the distribution of the original data set. Stratification means the result much better, trains in each class, so the result could be better. Um, so that is basically it. We use this type of test scenario instead of just this, unbiased scenario. To sum it all out, I would like to just say, suppose we have the concept of overfitting, underfitting, and best fitting. So I'm just gonna summarize it with this concept. Um, Now let me just say what is let's say underfitting. What is underfitting? So underfitting is when you have let's say underfitting is when you have a let's say train a model, and your train model is, suppose the result for your train model is 75%. okay, which is not good at all. And when you go in the testing phase for your model, your result becomes 65%. So the train was bad and the test was bad. This is underfitting. Your model is underfitting and is wrong. You're not supposed to do this. Let's look at overfitting. What is overfitting? Okay, overfitting is when your training model, okay, the training model, let's say was um, 95%, okay, a really good training part you did. But when you came out for the test, when you wanted to test yourself, you resulted with a 75% result. So the training was really good, but the testing wasn't that great. And that is when you have overconfidence in yourself and you just, mess up here. So that is not great as well. You don't want a model to overfit and you don't want a model to underfit. What do you want a model to do? You want a model to have the best fit. The best fit model is the perfect model to choose from. So the best fit model is meaning when you have the training part, suppose you train and you got a result of 80%, okay, training. And what happens in the test part is when you test it, you might get lucky and you get a really better result than the training part. You could That's possible, but it could also be possible if it could be slightly less. But let's say it's 78%. The Let me just clear that out. Okay, 78%, which is the test. So 80% is the train and 78% is the test. This is also good. So you want a best fit model, and that is the crux of machine learning, where you want the best fit model. Um, and I remember I went over the diagram in my part where percent
The
the
audio.
let me just clear that out.
And those,
Yeah.
okay.
So awesome. Thanks for letting me know. 78%, which is the test. So 80% is the train and 78% is the test. Now the last part that I want to go through is the small image over here. And when we get this finalized, and then we just basically conclude. Now let's see how the machine learning works. We have raw data, remember? The data, like if you're following me along with my last videos where there wasn't these kind of audio problems, and the whole live streams went great, perfectly. And hopefully in the future these things won't happen ever again. I'll try to fix these issues that ever occurred. So what happened here? We have raw data. So we had raw data, like in Pokemon dataset or whatever. We use exploratory data analysis. Exploratory data analysis means to explore the data to find different values and anything that's new to the data and discover it. Just completely discover it. Then you clean the data if there's any, problems with the data. You manage missing values, the NA values, the missing values. You might completely remove the NAs, or you might replace the NAs with some mean values according to what the column is or what the feature was. If we talk about the next step after this is the basically the life cycle that would occur for machine learning. Then we pre-process the data. Pre-processing means you basically uh, use pre-processing techniques. And to get everything cleared, we have two types of data. We have categorical data and when we have numerical data. If we look at categorical data, there could be numbers. Uh, if I open up a text document, categorical data could be like names. Suppose name of a animal, cat, dog. This is categorical data, okay? There's just names. But in numerical data, there's just values like 100, 1000, and those. Okay? So these are two types of data, right? Now, categorical data could have further two subtypes. No, the first type is nominal. Nominal is just names. Let's suppose the name of just some data, say New York. Now, it's just a data, right? There's nothing to it. There's no relationship. But then there's ordinal data, which is also a type of categorical. It could be in terms of order. Let's suppose if we talk about the size of a shirt, we have small, medium, M, and then we have large, right? I'm just writing short because, and then we have XL, so extra large. So this is the type of ordinal data. But if we talk about a nominal data, we'd have just numbers, right? We'd have integers, whole numbers, or floating points. You could actually you could say pre-process this and use scaling, which is a concept in machine learning that you could use min-max scalar or standard scalar. If we go back to the, let me see, Excel. So if we go back to the scaling part, let's see, scaling part. If you, yeah, so my cheat sheet here, I have I have this scaling that I did mention up in my cheat sheet. And I'll recommend checking this cheat sheet out. And the first five people who introduce themselves in the Discord channel will get it for free. And if you just want to support me, you could generally go to the Discord server. I mean, or you could also go to the chat page where you could see the Gumroad and just buy it. That would just support me. From sklearn.preprocessing, we have import min-max scaler. Remember, these are just Python codes, Pythonic code that you could just write. It's perfectly correct. And you could use these type of scalings for your numerical data. Remember, not categorical, but numerical. Um, we could use simple imputer for missing NAs. That's a technique as well. And for scaling, we could use, this min-max scaler, and then this other one is called standard scaler. So you could see over here, this is the general formula of a standard scaling, and then and we use min-max scaling, which is this one over here. So these are the two ones, just a general overview. Then we basically scale the data to make it in a consistent range, so it doesn't be like over consistent. Suppose one guy's revenue, or maybe one guy earns 70, let's say $20,000, okay? But let's say one guy earns $1 billion. So this is out of range. So to fix those, we use scaling technique, and the one is standard, and then the other one is min-max scaler. Okay, so this is just an information that I wanted to say, and that's exactly what you're doing. You're basically scaling it to perform some general formula to do this. Yeah? So this is just something that's going on, making it consistent, making it in a particular range, so that it doesn't, have outliers. Outliers when you find a mean. So you don't want some data that is going away from the mean, and something that's before the mean. So something in the middle is consistent, and that's where it's going to give you better results for your machine learning model. So which is very important to have correct data. Okay, so that's why we have to perform all of these steps. Um, if we go back here, we have feature engineering. After this, feature engineering is so basically when you have preprocessed data, you could split it to training and test split. But feature engineering is a process where you actually create more features. The more of the features, the better it gets, right? The more the features, and you train it and try to find a better result. And then you selection. You feature selection, meaning it's another process where you select the best features that give you the best results. And you choose the best ones that give you the best results, and you hyperparametric. It's called hypertuning it. You hypertune them with better parameters, and you could use processes like grid search CV, which is a really amazing process. And if you guys want to know, I might do something in the future related to this. But it basically tunes out the parameters and gives you the best working parameters, which will give you the maximum value for your machine learning model. So you go through all of these phases to end up with a result that would give you the best machine learning. And then you apply some machine learning algorithm like a logistic regression or decision tree or next boost or whatever. And at the end, you'll have an amazing machine learning model that would process the thing. But to automate this as a whole, you would use a pipeline. So a pipeline would just, simulate everything step by step, and you don't have to do everything explicitly one line by line in Python. So we just have to make a pipeline, and everything will be simulated, and just everything will be done really amazingly. So this is machine learning. I hope you got like a gist of what actually happens behind the scenes. I didn't go into the code aspect part, but I might do that in the future. If you have any problems or questions, just let me know. And I might now I'm actually concluding. So yeah, just let me know what you thought about this. This is machine learning. I hope you got like a gist of what actually happens behind the scenes. I didn't go into the code part. I didn't go into the code part. Any questions before we conclude? Just let me know, guys. I might conclude. Sorry about the issues. I'm gonna fix it up So I'm gonna fix up the stream and whatever, was working. Yeah, yeah, definitely. So whatever, the parts that were accurately worked, I mean, where there was no issues, I would trim those results that would have, the issues with the audio, and at the end there would be a perfect stream on the channel, so you would be able to rewatch this, um, without any flaw. And I hope you got something out of this stream, although there were some issues. But the ultimate goal here was that you understood something or you got something out of this. And definitely look into future streams that would happen next month, and definitely we'll try to touch the coding part where we would create our model and test it and all that. It depends on the demand, and yeah, I'll be checking on the Discord server. You could support coding cleverly, uh, becoming a patron, and you could go here. Thank you, Parker. So this is the Patreon page. Yeah, awesome. Yeah, because this is important. The recording will be available and you could re-watch it, and it's gonna be then perfect because I'm gonna edit this stream, and wherever their issues were, they're gonna be removed, and it would be a complete live stream where you could go and watch the stream sessions. Just the final thoughts here. There's a Coding Cleverly Patreon page where you could become an official Patreon and support me. You could either do a supporter $1 a month, a $5 a month, or $25 a month, and you'll unlock some exclusives over here. I'll give you the cheat sheets anyway. You'll get free cheat sheets. All other Gumroad cheat sheets will be free, and I'll give you access to other things as well. And you'll unlock all these amazing videos that I have that are just for my Patreon viewers. So go check that out and stay tuned for more sessions. Definitely will go into programming aspects, because I'm a fan of the coding parts. But the general gist of the concepts were important for this because people are supposed to know a little bit how machine learning actually works. Just a general overview if we don't go into that technical detail. So thank you guys, thank you everyone who were into the stream, who were still sticking with me all the way to the end. Especially thank you guys who didn't go away and just watched me through and saw all those issues, and thank you so much guys. See you guys next time.